for our Genius Hour project, I will be looking at Do Dogs Love Us and our relationship with our pets. I've always been a dog person. I grew up with 2 Siberian Huskies, and eventually once they passed, we adopted my dog Paul, who's in the top right corner there. And I would like to think that they care for me, but I honestly have no clue. Do they just see me as somebody that feeds them, and is that why they love me? I want to know, do dogs experience emotions? I know that my dogs sometimes realize when I'm upset, but do they get upset? I wanted to know what exactly is going on inside their heads. One study I found showed that dogs not only recognize but possibly empathize when humans are in distress. Dogs showed higher stress responses indicated by heart rate when the human in the room pretended to cry, even if the person crying wasn't their owner. A different study found that in this same situation of a stranger crying, the dogs recognized the human's distress and attempted to comfort the stranger. The graph on the right shows that dogs responded more to crying than to humans talking and laughing, which makes me think they understand, okay, they're upset. But while these studies show that dogs may recognize human emotions, they didn't explain the dog's emotions and didn't look at the dog's actual brains. The most in-depth research I found was done by somebody I was already familiar with, neuroscientist and author of How Dogs Love Us, Dr. Gregory Burns. Dr. Burns explained that a dog's brain is roughly about the size of a plum, depending on the size of the dog. And just like human brains, dog brains have an amygdala, a cerebellum, etc. And those parts of the brain have the same functions in dog brains as they do in human brains. So for example, the hippocampus is used for memory in a dog just like it is in a human. One primary area that differs is the size of the cortex and how folded it is. The folding of the cortex allows the brain to pack more brain surface into one area. The more folded the cortex is, the more brain power you have. Dogs have smaller cortexes and less folds than humans. While a human's frontal lobe takes up the whole front third of their brain, a dog's frontal lobe only takes up about 10% of their brain. However, dogs have a significantly larger olfactory system, which is about 2% of their total brain weight. Humans' olfactory systems, on the other hand, are only about 0.03% of our brain weight. Dr. Burns used fMRIs to look at the dog's brains and their responses to certain stimuli. An fMRI, as a reminder, is a type of MRI that creates 3D images of the brain and can highlight specific parts of the brain that are active. fMRIs track blood flow by tracking oxygen and can infer neural activity because active neurons demand more oxygen. One advantage of fMRIs is they have good spatial resolution and can show exactly where the activity in the brain occurred. One disadvantage is that your subject has to be completely still in the fMRI machine, which you can probably assume was a little bit difficult when it came to keeping the dogs and getting their fMRI scans. So, in humans, the reward system refers to a group of structures that are activated when we experience something rewarding. During this experience, our brain releases the neurotransmitter dopamine, and because of that, most of our reward system structures are found along major dopamine pathways in the brain. The pathway most associated with reward in humans is the mesolimbic dopamine pathway, which starts in the VTA, one of the primary dopamine-producing areas in the brain. When we experience something rewarding, dopamine neurons in the VTA are activated, which raises dopamine levels. Dr. Burns used the fMRI to look at the dog's caudate nucleus, which he calls the heart of the brain's reward system. The caudate nucleus is found in humans as well and is in charge of the execution of movement as well as learning, memory, reward, motivation, emotion, and in romantic interaction. For Dr. Burns' study, dogs were shown a toy for 10 seconds, which was then followed by either a treat or their owner coming into view and praising them with a good job. Dr. Burns found that 13 of the 15 dogs' caudate nuclei had equal or greater activation to their owner's praise than the treat. Here's another example of where it is in their brain. But this result alone makes me think that we are more than just necessary providers to our dogs, and they may truly love us. Dr. Burns eventually moved on to dogs' responses to the scent of a familiar human. He repeated a prior experiment where dogs were given a hand signal before being given a treat. However, this time, instead of a random scientist giving the signal, he had the dog's owners do it. According to Pavlov's findings, it shouldn't matter who gives the signal. A dog should get excited when anticipating food no matter what. However, Dr. Burns found that there was a difference. While some dogs' reward systems lit up more to a stranger or computer giving this food signal, others responded more to their owner. And this opens the idea that dogs have different personalities and/or different relationships with their owners. And here's an image of what Dr. Burns saw. You can see the parts of the brain lighting up in the dogs. So overall, the information I found does answer a lot of my questions about dogs having emotions. While these emotions may not be as complex, I did find that dogs can get excited, nervous. Dogs responded to people based on how they think we're feeling, proving that they can interpret our emotions. In addition to them recognizing our distress and attempting to comfort us, the dogs themselves also showed distress in a response to our distress. Studies also show that dogs experience the same excitement in response to our praise as they do to food, which may prove that they genuinely enjoy pleasing us. And overall, based on the research that I found, I would say that this dog, looking at me in his Halloween costume, loves me just as much as I love him. And here are our references. Thank you.